basically, I started for the next topic exactly with this dynamic binning of my data. So obviously you can do this for all your KPIs or all your measures. So you could change this and can say, okay, I want to do it for profit. I want to do it for something else. So you definitely can change it. And the next step, the next thinking step of mine was, okay, now I know each bin and I know how many is in this bin. What is if I say, okay, I want to see this by revenue and I want to know which revenue was made by my top percent of customer, my second top percent of customers, and so on. So if you are if you have studied economics, there's something called Lorenz curve. It's about the distribution of income in a country. So it says the top percent of people in the country have maybe 50% of the income. And you can do the same thing for your customers or your clients. You can say, okay, my top percent of clients are responsible for 10% of my revenue. And this was a question I asked myself, okay, can I do such an analysis dynamically with Power BI, dynamically with DAX? And the short answer is yes, I can do. So yes, I can do. So I performed this, and this is the final result. But now we will step into step by step what I did. And we explained the binning and the use of virtual tables is something I use yet now again in a little bit more, I would say, advanced way, because we are using dynamic tables or virtual tables and use them in a different way again and again. So let's have a look. So the end product will be this. So we can even use this in small multiples. We can also filter this. So everything is dynamically, and we see there's not so many rows which has to be calculated. And in this case, it's also quite performant. So we will see this later on the big data model. But let's jump into our data. And we want to start. So basically, I have 3 calculations, but all the 3 calculations have the same principles. So we always start the same way, only what we are using as an output is changing. Once we use the revenue per percent, once we use the percentage of the total, so only the outcome is changing a little bit. So let's start with the percentage of the total. Arthur is smiling.
Yeah.
You already know
Nice
this.
measure. Yeah.
Yeah, and I want to know percentage of revenue per percent of customers. So I want to know which percentage does my customer have. And the first thing I need is, again, I need a table, a virtual table, and I use variables. And to be honest, I have no clue how I could do this without a variable. So I have no clue.
You shouldn't.
I shouldn't. Yeah. And the cool thing is about variables, you can structure your code quite easy. You can say this is the first, second, and so on, and you can move like like a text. So we can start with our first variable, with our first part of the text. We need a group where we say, okay, we want to know the revenue per each customer name. We could also do this per customer key. So would be the same. Maybe it's better to do it for customer key. I now used customer name. And I said, okay, please summarize. So summarizing, creating a virtual table. And the first thing is I have to say which table I want to group or I want to summarize. It's the table sales. I want to use the granularity, and I use the granularity customer. So I bring everything together for the customer, and I say I want to know the revenue for each customer. So I get a new table containing all the customers with the revenue. So this is our first virtual table. We are starting with a table with all customers with their revenues. So second step is, because we later need the count of how many customers are in our data, I just said, okay, I want to use the customer table and say, okay, I need the count of all customer tables. I guess there's also, this could be a little bit easier made, but it's okay because this is not the part which makes the data, which makes the performance bad. So I say, okay, I want to use all my customers with some revenue. So I only use customers which have at least bought one thing. So
And
they
then
have,
this is then dynamical, right? Because it's a virtual table, the outside filters are passed in. So if you have certain filter of a country or
yeah,
region,
exactly. So
this is cool. That's why you shouldn't do it in Power Query and just
yeah.
remove the blank values there. No, you shouldn't, because this is a dynamic way.
So now we know the total number of customers, and the next step is a little bit, I would say, different thinking, because I was thinking about how I can get a percentage where the customer is located. And now I say, okay, I want to rank them. And I want to rank them by the new column revenue. So this sorts me everything by revenue. We will see this is not perfect in this small kind of data set, but we're getting better if we have a big data set and have more not similar values. So we will see some small problems because if customers have the same revenue, they have the same rank. And this is some kind of a little of problematic, but we will see this later. So now we say, okay, each customer get an own rank. So we add a new column for each customer with an own rank. So now we know, for example, the top customer gets rank number 1 with 1 million euro revenue. So the top customer is set here. Next step is we do not want to see every single rank. We want to see the share of percentage. And now it's coming into play that we calculated our customers total. And we know if I calculate the customers total, I can divide my rank by my customers total, and then I got a relative position in the total things. Yeah, delta, thanks. And then I get the relative position of my customers in my data. So now, for example, I say 1 divided by 100 because I have maybe 100 customers. I got the relative position 001. So in this I do for all my customers. So I create a relative position by calculating all my customers dividing by as the rank of the customer dividing by the number of all. So this provides me with a relative position of the customer. Of course, this can be much more than 1%. It's going to be 100 something. And the next step is I say, okay, I round this. So I round this always up. And I say, okay, if I'm in 001, I'm in percentage 1. So I round this to total numbers to 1, 2, 3, and so on. To later compare this in my data. So this is the step where we creating, let's say, rank, a classification. So class A, 1, 2, 3, and so on. So here you could also bring in that you say, okay, I can use this also for ABC analysis. So next step. So now we know, okay, each customer has a rank. Each customer has a percentage place where it's relative in the data. Now we can say, okay, we create a table which is summarizing the virtual table. Now we're going and say, okay, we create a summarization of the virtual table. So we take this table, we created cast position here, and say, okay, we use this cast position and say, okay, we summarizing the percentage and calculating the total revenue for each percentage. We now got a next virtual table which says, okay, in this virtual table we know for each percent how big was the revenue, and this helps us later to say, okay, we can use this virtual table to now say, okay, I want to bring this in different contexts. For example, I can say, okay, which percentage has how many revenue and so on, and how is the share on the total revenue of this percentage. And here we are creating and say, okay, we use again a parameter table and bring this parameter table in from outside and say, okay, there's 1, 2, 3, and so on. And we always want to calculate this table if our percentage is smaller than our value we are providing from outside with the parameter. So, and here we're seeing this is our new table, and this new table then gets summed up, and in the end we calculating the total sum until this point and dividing this by the actual total revenue, because the revenue here is only filtered from outside, not filtered from anywhere inside this this formula. So, and when we have done so, we are going just to this chart, and here we see, okay, I used, this is a curve, this is the formula I described. So it's always calculating for each percentage what is the total amount, total revenue before this percentage in our virtual table, and then divides this total revenue by the absolute total revenue. So if I say, okay, for example, if I click in Australia, we see everything is filtered in Australia. And something I then brought in is just another parameter that I can say, okay, I want to slice to 50%. And now I see, okay, on 50%, I got 95% of my revenue. So 50% of the customer are responsible for 95% of my revenue. And here, this is also done with two types. One is I brought in a X line, so a constant X line, which say, okay, please mark this constant X line, and this is basically the parameter here. And the other thing is I brought in a new filter, so a new measure, and this measure, you can see it's exactly the same until here, and here I just say, okay, this value is exactly our parameter, and then I just came up with these parameter, and here we can then see two lines. One is calculated dynamically for each percentage, and one is calculated exactly for this parameter. So we got always the possibilities to slice and dice and see what is on this line. Yeah, and here I used just a little bit colorization, said, okay, if the bin is under or over, it's white or blue. So, and the cool thing is you just can use it with combination, for example, like small multiples, as I can see here. It also works perfectly with the use of parameters, as you can see. So you have a lot of possibilities to really analyze the risk or the potential of your customers, of your products. So you can name it what you want to use as as something you want to analyze. What is the impact of your top 10% on revenue, on profit, or something like this. Well, so this is more or less the basic settings, and we see a lot of we see sum X, we see virtual tables, we see summarize, and it works, but obviously this is not a solution you should use if you have huge amount of data. So if you have really massive amounts of data, this is not the thing you should go to, because this is really computing a lot of things in the back end. And we just can have a look what is happening if we look at bigger data. So I've done the same. So I have another map, and now you see, okay, this is not calculated on 70,000, it's calculated on 7 million. What is if I go and say use this kind of data and I refresh this, and you see the is going on, it's using a while, and of course now the DAX query is much slower. So you need nearly 5 seconds to calculate everything. But I think, okay, we're talking about 20,000 customers, and we're talking about 8 million rows of data which have to be compressed. So I think it's not the worst thing ever.